Hey guys, FirstinWeather here. Welcome to my 2017-2018 winter forecast recap and 2018 summer forecast. And again, this is presented by FirstinWeather. So, going back to the winter of 2017-2018, it definitely was a very interesting winter for sure, especially in Central Virginia. We had many winter weather events, with and all those events were generally minor in nature. We didn't really have any blockbuster winter storms this year. There were basically little pockets of winter weather. So one storm would have 2 inches of snow, and the next would have 3 inches, the next would have half an inch. And we actually had a snow event in April in Central Virginia, where many locations saw half an inch to an inch of snow, which was quite amazing for that time of year. So, here's what I forecasted temperature-wise for the months of December through February, and these are temperatures once again. So, as you can see, I forecasted slightly below average to below average temperatures in this area right here. Then I forecasted average temperatures in this area right here, in this white. I forecasted slightly above average temperatures in this orangish, this light orange or dark yellow shade. And then I forecasted above average temperatures in the southern third of the country. So, now let's go to precipitation. So here was my precipitation forecast for the months of December through February 2017-2018, and I basically predicted an area of above average precipitation in this area right here, and in this dark green right here. Then in this light green, slightly above average precipitation. Then in this white area, average. In this yellowish area, slightly below average precipitation. And finally, in this orange area, I predicted below average precipitation. So now let's see how I did. So, what actually happened? Well, to the left is my forecast, and to the right is what actually happened. And this is a map from NOAA, and it's basically an analysis plot. It uses these different sectors to make plot the various temperature anomalies for a certain period of time. And as you can see, this is for December through February 2017-2018. And you can see that I predicted basically above average temperatures in the southern third of the country, and basically a dome of above average temperatures in the west. And as you can see, that kind of did play out. You had this little above average dome right here, and then you also had slightly above average temperatures in this area that I predicted, and you also had that right here. You had above average temperatures right here. I was a little off when it came to temperatures in this area. I predicted above average temperatures here, which did not play out. We saw average conditions over here. And now when it comes to the below average temperatures, which I predicted in this wide swath over here, I was again a little off. We didn't see those below average temperatures form over here. We saw them form in this area, so I was right about that. But then again, we never saw those below average temperatures form in this area right over here. So that was something that I was incorrect about. Now, let's go to precipitation. And in this forecast, I really was wrong. I screwed up pretty big time. As you can see, I predicted slightly below average to above average in this area, and California basically was completely below average. Then I predicted below average over here. We were actually above average. Here I predicted above average. We were average. Really just completely off in terms of precipitation. So for my precipitation forecast, I really did not do good this winter. And now in the next slide, I'll explain why I did not do that well in my temperature and precipitation outlooks. So what went wrong? Well, it's the darned NAO, the North Atlantic Oscillation, and it's basically an area of waters basically south of Greenland, and it has big effects on our short-term weather. So the NAO was unexpectedly positive for the duration of the winter months. So that means the waters south of Greenland were much warmer than normal. And as you know, I forecasted a negative NAO, which is when the waters south of Greenland are actually cooler than normal. So we had the exact opposite, and that completely slaughtered my precipitation and temperature forecast for many locations in the United States. And as you can see in this graphic right here, this is December, this is January, and this is February. You can see that the NAO was positive. You had 0.88, 1.44, so strongly positive. And again in February, 1.58. That's a strongly positive NAO. Instead, I predicted a negative NAO, and you had the complete opposite of that. So that really messed up my forecast quite a bit. So, my overall grade for this winter forecast. In conclusion, I would give myself a C- for this year's winter forecast. Again, I was pretty off in my temperature and precipitation forecast. Due to the NAO, my temperature and precipitation forecasts were well off the mark in many areas. So in the future, I hope to better predict these various oscillations, the NAO, the PDO, the AMO, in order to give you the most accurate forecast possible. I will take the lessons I have learned from this winter and use them to improve my forecasting skills in the future. So now that being said, let's get straight into the 2018 summer forecast. So here's a quick note. For the 2018 summer forecast, my forecast will be for the astronomical summer, unlike my winter forecast. This means my forecast will be covering the time period of June 21st to September 22nd. So I'm recording this video the day after June 21st, the first day of summer. So, and many of you will be seeing this video tomorrow, June 23rd. So, here is the summer forecast from the National Weather Service, and many meteorologists use this as a guiding tool. I just thought I would include this just for the purposes to see what other people are forecasting. And as you can see here, they're predicting an area of above average temperatures right here, equal chances right here, and above average precipitation here, and below average precipitation here, with another area of above average precipitation over here. And in my forecast, I'll actually explain why I disagree with this forecast, and where I am actually different from the National Weather Service. And this year my forecast actually differs quite a bit with the National Weather Service when it comes to my summer forecast. So now we have to look at some of the models. So this is the CFS V2 model, and this is the forecast in temperatures. You have a little dome of above average temperatures over here, above average temperatures over here, and then you have an area of slightly below average temperatures over here with average conditions in these areas, and then you have above average precipitation here with slightly below average precipitation in this area and then in this area. Now if you look at the CAN-SIPS model, which is another climate model that meteorologists use to make long-range outlooks, and as you can see, it kind of has the same thing when it comes to temperatures. You have a dome of above average temperatures here, same thing here, then you have average conditions here, and for precipitation you have slightly below average precipitation for this area right here, and average conditions elsewhere. And finally, the last model is the NMME. It's an American model, and as you can see, it has kind of the same gist for temperatures: above average here, slightly above average everywhere else, precipitation slightly below average over here, and above average over here. So now, what did I use to make my own forecast? Well, to make my forecast, I used those weather models, and I used my own knowledge. And that knowledge was basically using various weather parameters such as the PDO, the NAO, and the El Nino phase to make my forecast. So this summer, I'm fairly confident that we're going to be in a neutral to slightly cool phase PDO. What that means is that you have cooler than normal waters over here, warmer than normal waters over here, right? You can see this big dome of above average waters, right? And then that's surrounded by cooler than average waters. One interesting thing to note is that these waters over here are also above average. But the thing is, this area of water right here is so above average that it's basically causing these waters right here to act like cooler than normal waters, which is in essence is a cool phase PDO. And a cool phase PDO is basically when you have warmer waters here and basically cool waters around it in a horseshoe shape, and that is what makes PDO in the cool phase. Now, I also believe we're going to have a positive NAO, and again, I forgot to include this. This is a forecast model that predicts the sea surface temperature anomalies for various time periods, and this is for July, August, and September. And this is basically an average of all the other smaller models that basically come up together, make an average, and it spits this out. And it's predicting a positive NAO in this area. As you can see right here, this big dome of above average sea surface temperatures, and that's what makes the NAO positive. And then we're going to be going from the neutral phase to a weak El Nino, and I forgot to include a graphic for this, but that's okay. So basically, a neutral phase let me explain one more thing actually. Let me explain what the El Nino / La Nina / Enzo is, and that's basically, didn't want to do that. So that's basically the waters in this area along the equator, right around here, from the western coast of South America all the way to Indonesia. All right, and when these waters are warmer than normal, you're gonna have an El Nino. When these waters are cooler than normal, you're gonna have a La Nina. All right. And these waters right now are slightly warmer than normal. So when the water temperatures are 0.5 Celsius to negative 0.5 Celsius above or below average, you're in Enzo condition. So it's neutral, not too warm, not too cold. So it's not an El Nino, it's not a La Nina, just right in that middle, which is a neutral, which is basically Enzo conditions or neutral conditions. Once it goes above that 0.5 level, you reach the El Nino threshold. So if it's 0.5 or above, you're in that El Nino threshold. And I believe that in the first month and a half of basically July, in the first half of August, you're going to be in neutral conditions, and then after that, we're going to enter the El Nino range, 0.5 and above. So that's why I have these arrows that show the progression from the neutral to the weak El Nino phase. So what I did then was I realized I went through all the years and I said, which year had these exact same conditions? This is something that meteorologists commonly do. This is one of the best ways to forecast using analog years. And the year that had what we're having right now was the year 1967. In 1967, you had a positive NAO, you had a cool phase PDO, and you had a neutral phase Enzo condition, basically. And so, which is quite similar to the neutral phase transitioning to an El Nino. And that's what I'm predicting will happen this summer. So what I did was what almost all meteorologists do is you go back, see which year had the same conditions that you're forecasting, and see what happened in that year. So in this case, 1967. So now let's see what happened in 1967 for the summer. Well, actually, first let's look at the parameters. My bad. So in 1967, as you can see, the NAO was positive, 0.41, 1.44, and 0.93, all above 0. The PDO was negative, or cool phase, negative 1.22, negative 1.63, and negative 0.69. All of those are below 0. And you had the neutral, or Enzo conditions, negative 0.22. July, August, September 1967, so negative 0.2. Alright, and as you can see, the average is negative 0.2, which is neutral Enzo conditions. Since the forecast this year is for the average to be just below 0.5, because you'll be in the neutral conditions first around 0.2, going up to 0.6 or 7, which is El Nino, going from the neutral to El Nino phase, I adjusted for this negative 0.2 by making the forecast, my summer forecast, drier in the north, wetter in the south, and warmer in the north to account for this difference, because the El Nino typically you have wetter conditions in the south and drier conditions in the north. So, what happened in the summer of 1967? Well, from the months of July to September, you had an area right here of well above average temperatures, basically the western third of the country. And then the eastern 2/3 of the country had below average temperatures, with a little pocket of above average temperatures right here. Then for precipitation in 1967, you had basically this general area of average to slightly above average precipitation, and also in the northeast. And then you had this general area of below average precipitation right here and right here. So now, accounting for the differences from the negative 0.2 and 0.5, I made my forecast here wetter. I made it drier over here. Then I made it warm over here, a little cooler over here. And yeah, so that's my forecast for this summer. And now when that's put on a map, we'll see how it looks like. So here is my 2018 summer forecast for temperatures. As you can see, I essentially have this dome right here of above average temperatures in this orange shade. In this yellow shade right here, I have slightly above average temperatures, so slightly above, not above, but slightly. So that would be like 0.5 degrees, 0.8 degrees. Then in this white area right here, I have average conditions, so average temperatures. Then in this light bluish color, I have slightly below average temperatures, and in this bluish color, this dark blue, I have below average temperatures. And for Central Virginia, which is right here, you're basically on that dividing line between the average and slightly below average temperatures. So now, going to precipitation for my forecast, 2018 summer forecast. As you can see, I have basically slightly above average precipitation for this light green area, which includes Central Virginia. And I have this little pocket right here of above average precipitation. Now, in this white area, I'm predicting average precipitation. In this yellow area, slightly below average. And in this orange area, below average precipitation. So orange below, yellow slightly below, white average, green slightly above, and dark green above. So that concludes my 2018 summer forecast. Hopefully my forecast this year will be more accurate, and I definitely am feeling more confident for this summer 2018 forecast than my 2017-2018 winter forecast. Again, if you have any questions, comments, or concerns, please feel free to let them be known in the comment section. And I hope you enjoyed this video and presentation, and I'll see you next time.